What's up, developers? Stefan here from Be a Python Dev, and I'm here to talk about the 6 most popular data structures and how we would implement these in Python, or using them in Python, or just teaching them using Python, because Python's fun. So anyways, the 6 popular data structures that we're going to be talking about today is the array, the hash table, the queue, the stack, the list, and the tree. If you're ever programming any kind of complex program, whether it be a game, an enterprise application, a web page, well, more specifically a web application, you're going to need these data structures to organize your data and be able to do different kinds of algorithms with them and all the fun stuff. These are the backbone, the building blocks of your application if you want to be able to organize your data in any kind of way. For example, if you have a web application with a lot of customers or people, you might represent them in a stack of objects, and you might put them into a hash table to be able to access them later on. I think databases use a version of a hash table and a graph scheme to be able to look up stuff and get data really fast to the people that care about it. For example, if you're a person on Facebook and you posted something last week and you want to be able to see what that is, the date might be like the hash, and then you can get your post from last week and get it in instant time. So now that you know that, let's dive into these data structures a little more. So Python doesn't actually have an array in the same sense as like Java would, but it does have like a modified array/list hybrid thing that lets you append things without needing to resize and be able to traverse through it and still do index lookups. But for the sake of this conversation, we're just going to treat the Python array like it is a Java array, even though it's not. To get an allocated little memory space for our application to be able to store data in, we can create an array ourselves by saying our array equals, we'll populate it with zeros, and then we'll give it a size of 10 slots or different bins to put data into. So this will give us 10 different slots, which will be allocated into the memory in the back end. Python and the Python's interpreter will do all that fun stuff for us. So just to show you that we have an array here that has data, we'll go ahead and print this, and we'll run this real quick. And the output should be in the bottom, but it looks like my big old head might get in the way of that. So let me move me real quick. This isn't actually moving me. I'm moving the wrong thing. All right, let's move me over a little bit. Okay, now that I'm moved, we'll go ahead and run this, and we'll see our 10 zeros in a little bracketed array type thing. So let's run this. And that's the wrong thing. I'm not actually running a test. We'll run the Python file. All right, so down here in this thing, you can see 0, 0, 0, 0, 0, 0, and that represents our array, which is just a container of memory to store values in. The benefit of having this kind of storage container is we can add things into specific slots. So we can say our array2, which will actually be the 3rd slot in our array right here because arrays are 0 indexed. So this would be 0, 1, 2, and so on. And we'll go ahead and give this a string value of 2. One thing that's fancy about the Python array that you generally can't do with Java arrays, when you create a Java array, it needs to be a specific variable type. So it's either a string, or it's a float, or it's an int, and you can't really go between all the different values. But with the Python arrays, we added the string 2 in our first value, and in the 5th index, we can add an integer. So I'll go ahead and show you how that works here, and we'll print this out so you guys can all see the funness. Go ahead and run this. All right, so you can see our same 10 slots. Our 2nd index has the string 2, and the 5th index has the integer 567. Other things we can do with this, we can loop through it to print all the values. So for val in our array, which is actually a fancy array list type thing, but anyways, we're just treating it like this, and we can print our value. So this should print 0, 0, the string 2, 0, 0, integer 567, and other fun stuff. So you can see we're printing it on a line, and we're using a simple for loop to iterate through the array. The reason I went over this is because if we have lots of values in our array and we want to know specifically where data is for our customer or our person value or our account in a web application, you would need to traverse through this and traverse through all of this to be able to find specific data that you're looking for. If you had a billion entries in an array, obviously looking at every single value in the array is going to take some time. That time is dependent based on your system, how fast your CPU is running, how many other processes are running at the same time so that your computer can allocate and split work and all that other fun stuff that you learn in computer architecture. But if val equals 3, print, this is our data. So this is going to run once, or this is going to print once, but it's going to run 10 times. If we don't want to keep running it, we can break our loop with break. So this will run actually 4 times, because 3 is in our third index, which is actually the 4th value of the array. If you have any questions so far, you're not following along, just rewind it back, play it a couple times until you do get it. Eventually it'll stick up. I don't want this video to be 800 minutes long, as it's already kind of running, or it's already kind of going that way. Anyways, this is our data. You're probably not going to search through an array like this of strings. This isn't that practical, but maybe this value is an email address, and then the thing that is actually in it is all the other data for that user. And that's something applications do all the time. And you can easily have 1 million customers in an application. But anyways, I'll just show you that this works. Maybe make this a little more practical. We'll print the value here. So in our output, we should see 0, 0, 2, 3, and then this is our data. So just to show you that that is kind of what's going on. 0, 0, 2, 3, this is our data down here. So exactly what I said would happen. And that search, it was pretty quick. But again, if we had 1 million entries and our data was actually the 900,000th in the array, that would take a long time. The reason I am going into this kind of lengths to explain that is because it shows why this data structure actually exists. So the hash table allows us to find data in constant time, given that we know the value and where it would be in the array that backs up the data. So to talk about hash tables, I'll go ahead and copy our array again. This will initialize it to a new value. I'm going to go ahead and delete all of this stuff that we just talked about. Maybe I won't delete it just in case people want it later. I'll go ahead and comment this out. Maybe break it into a function is a little better. So in Python, we can just declare a function like this. Let's move all of this in here. So we're not actually gonna zero it out. We'll just move it so it doesn't get initialized anyways, because it's gonna be in a function scope. And to create a function in Python, we just do def array demo, and then the brackets, which tells the interpreter that this is a callable function of this name with this def. I don't think def is actually right, is it? Maybe it is. Maybe I'm just being weird. Okay, it is. Yeah, so define the array demo function, and it has no arguments. Arguments is a different subject. A lot of you probably know it. If you don't, I'll make a video on it eventually. Subscribe to the channel to look for that video, or just go search it. Python Geeks for Geeks is a great resource for syntax and all that other fun stuff. Also realpython.com, I'll give them a shout out. I've learned a lot from them when I was originally learning Python. So anyways, this is our array demo. We'll go ahead and leave the caller in here, but we will comment this out so we aren't actually going into our function for this. I'll take a step back there. What this does is it will call the function, meaning that it will run something that the script knows about, matching the same name. And then once we call this, we go into all of this logic down here, which declares the array, sets some of the array values, does a little for loop on the array and breaks it, kind of like we all talked about. But I'm going into it in a little more detail to kind of make this stick a little better. All right, while editing this video, I realized that it's been running kind of long, and I don't want to overload your brain out there by giving too much info at once. So I'm going to separate out what I've recorded for arrays and hash tables, since hash tables is an even more detailed subject, and that video segment is already like 15-20 minutes long. I will release that as a follow-up to this video. Definitely subscribe if you're interested in learning how the array is used to speed up the lookups using the hash table, kind of data structure, paradigm, theory, all that other fun stuff on top of it. That's going to do it for this video. Again, like it if you learned anything, and definitely keep an eye out for the next data structures in this series, where next one, again, like I mentioned just now, hash tables, and then shortly after, we'll talk about the queue, talk about the stack, then a list and a graph. Actually, not a graph, a tree. So we'll be using a tree. Those later two, they're the nonlinear data structures that everyone kind of, oh my gosh, because it uses a node. It took me a little while to kind of figure out what it is. So hopefully I can teach it to you guys in a way that it'll stick a little sooner. And again, thanks again. Have a great day. Bye.